Modern software applications require users to manually interact with graphical user interfaces through mouse clicks, keyboard input, and navigation across multiple screens. Many routine tasks are repetitive, time-consuming, and prone to human error. Traditional automation solutions often depend on predefined scripts, APIs, or workflow rules, making them inflexible when user interfaces change or when tasks override. There is a need for an intelligent system that can understand high-level user intentions expressed in natural language and autonomously perform software operations in a human-like manner without requiring task-specific programming. So our project presents an autonomous graphical user interface agent capable of executing end-to-end computer tasks based on natural language instructions provided by users.
So how does the system actually work? At the core of our situation is a four-stage loops. First one is user code, then perception, reasoning, and final one is action. Then verify before repeating. It is that when the user gives the plain text instruction, something like find today's weather, that's all they need to do. The agent takes the screenshots and passes into the omnibus, which identifies every interactive element on the screen button, text field, icon, and converts them into a structured list the AI can understand. That structured UI instead go to the GPT, which reasons about the current situation and decides the single best next action to take. The agent then executes that action directly on the operation system, a real mouse click or keyboard input. Here is the key part. After every action, a new screenshot is taken and the whole loop starts again. So the agent is always reacting to what's actually on the screen, not following the fixed script. And running alongside everything is a safety monitor that can catch erratic or unsafe behavior before it reaches the OS.
This is the live demo of our application. So we asked the agent to create a folder and find latest OpenAI news and create a summary document of that news. So when we run this, start the planning, then it's going to take the screenshot to decide which state is currently UI is in, and then it's going to create the folder. Here it's basically used the Windows shortcut to create a folder and renamed it, and it's looking for the Microsoft Edge, and yeah, it's typing the latest OpenAI news, and it's going to grab those news, and again it's going to open the notepad to create that document, and then it's going to type that the thing which he found from the internet. So these are basically typing in the agent, so because the agent have this keyboard access, so it's going to use that keyboard to type this content, and again it's going to save these results. So basically here it's using the Windows shortcut keys to save the things, and finally it gives this summary result that what happened and the task was successfully done.
We have illustrated the capability of the agent, that taking a plain English instruction and autonomously driving it into completion. So here, using the weather query as an example, we have breaks down the multi-step autonomously looks like. The agent doesn't just return a text answer; it handles the entire chain of UI actions from opening the browser to typing the query based on a single user prompt. So, and also the second major thing is the adapt to changing UIs. A major technical breakthrough highlighted here is its adaptability. Because the system relies on vision, it perceives the screen after every single action. This means it doesn't break when website layouts change, completely avoiding the trap of brittle hard-coded automation scripts. And also here we have emphasizes the practical benefits. It drastically reduces the manual effort required for routine workflows, and it remains secure by validating behaviors before they execute on the operating system. And also ultimately here we have demonstrated that combining visual UI understanding with LLM reasoning creates a highly robust foundation for general purpose computer agents.